Okay, question number 4. First question is asking for the density of the steel ball. Now, obviously density is mass divided by volume. The problem here is they're not giving you it in, they're giving you millimeters and grams. So we've got to convert grams to kilograms. So that's 16 times 10 to the minus 3. And we've got to convert this, first of all, the diameter into a radius. Instead of being 16 millimeters radius, it's got to be 8 millimeters radius. And of course, we've got to make it from millimeters to meters. So when you do that, it all comes out. And of course, we know that it's going to be something in the region of, well, if water is 1,000 kilograms per meter cubed, we know the density of iron is going to be, or steel is going to be, something in the region of, 7,000, 7,500 is what we get here. So that's how we do that one. You can see here, I got this one wrong at the start, but basically they told you it drops. They put this height in here for me, and then they want this to be just before impact, which I read afterwards. So I calculated the wrong part there. But you want to say it's dropping from 1.27 meters. So mgh was half mv squared. That gives us v equals 2gh root 2gh. And then the next line is here where I've subbed in my values: 2 times gravity times the height, which is 1.27, and that gives us 5 meters per second just before it hits. Afterwards is the speed of the ball just after the impact, and that's where you do this little bit here. So basically it's the same mass, but instead of having 0.27, we know it's going to go up to 0.85, so I put in 0.85 there, and that gives us 1.4. So we now have 5 meters per second just before it hits, and 4.1 just after it bounces up. The change in momentum, of course, is mass times v final minus v initial. There's our mass again in standard form, or in SI units rather, and I've decided to make down the positive direction. So this is of course going up, which means it's negative, minus this distance here. The point is they have to add up. The magnitudes have to add up. The change in momentum comes out as being negative. I've omitted it from the final answer because we haven't specified really which is the up or down direction, so it's just coming out at 0.15. For part 5, the force, of course, is change in momentum divided by time. So we're taking this value from here and dividing it by the time that they give us for the collision. Of course, again, milliseconds. They're really testing us on our understanding of our prefixes and our units. 40 times 10 to the minus 3 gives us 3.6 newtons. And then finally, with reference to momentum, why should we specify the material, the plinth? Well, it might be compressible. If it is compressible, then this will increase the contact time and thus decrease the force. That's that.